So what we're going to do now is we're going to kind of wrap up this series by talking about how the ImageTaskGang application works. I'm going to show you the main test driver program. I'm going to run the main test driver program using both the command line version and the Android version just for kicks. First, let's take a look at how the overall application test program is designed, and then we will go and run that program. So at long last, we can take a look at the ImageTaskGang test program. And that's the main entry point for the Java version, the console version of ImageTaskGang. There's also an Android version we'll look at later. And we're going to run this, and I'll show you how it works. So here we've got ourselves an enum for the version of this test program that uses the executive completion service with a cached thread pool. And then we also have one with the executive completion service with a fixed thread pool. So those are the two tests we're going to run. And then we have the filters we're going to apply, the null filter and the grayscale filter. Notice that that's an array. And then the main program is going to parse any arguments we have, and it's going to run the test, and then it'll print that we're done. So let's go take a look at run tests. First thing we do is we warm up the thread pool, and that's just to make sure that all the threads get a chance to run, and we don't have to start cold, which will bias the results, depending on which one runs first. And then we're going to run through each of those enums. Remember, there's two of them, one that uses the cached thread pool, one that uses the thread pool that's a fixed size thread pool. So for each of those, we're going to delete any files left over from before. We're going to get the new list of files that we want to download. We then make ourselves the appropriate type of ImageTaskGang instance. And we do that by passing in the array of filters and the list of lists of URLs and the tests that we want to run, whether it be the one that's the executive completion service cached thread pool or the executive completion service fixed thread pool. And depending on whatever that switch choice is, we then make the appropriate instance of ImageTaskGang. Now, the first two parameters are always the same, the array of filters and the list of lists. And the third parameter is a string version of this enum, so we can use that for diagnostic purposes. And then the fourth parameter is which executor service we want to use. So here we're going to use the cached thread pool if we're doing this version here. And down here, we're going to make ourselves a new fixed thread pool with the number of cores, which is going to be, by default, it's going to be the number of cores known by the Java execution environment. That's another name for the JVM, by the way, but not all Java execution environments are a virtual machine. Some of them are compiled or ahead of time compiled. So that's what we're going to do. We're going to create one of the appropriate types of thread pools. That's what's going to get passed in to this constructor for ImageTaskGang, as you can see. So that's how we make the appropriate type of ImageTaskGang. Notice, by the way, I'm using the new style switch syntax here, which is a little less error prone than the old school way where you have to remember to put break. That's another reason to use newer versions of Java instead of using Android here. And then the next thing we do is we run the garbage collector to make sure that when we time the test, that always takes the same, well, we start with a clean slate of memory. Then we call time run, which, as you may recall, is going to time how long it takes to run this particular test. And we pass in the task gang, and that's what's going to be run. And so its run method is going to be called, and that's going to go ahead and start running the test. And what we're going to do now, I've looked at all the methods in here. Oh, this is warm up thread pool. It basically just warms things up so we get consistent time for this stuff. Okay, so given that, let's now go ahead and run this test. You can see here we're going to run the test, and it starts up. And the very first thing it's going to do is it's going to go ahead and print out some diagnostics saying that I'm starting. And it'll then run the executor service cached first, and then it'll run the one that's fixed second. And my computer is not plugged in at the moment. And so you'll notice that the fixed version takes longer to run than the cached version. Were we to plug in, I have a pretty good idea that it would have the fixed version run faster, but of course, your mileage may always vary. Fixed size thread pool has a pre-allocated pool of threads that's fixed to the number of cores. The cached thread pool, in contrast, will create a new thread unless there's already one that's been created that's idle. So oftentimes, the fixed one will be a little faster because the threads were pre-created. But again, your mileage may vary. You can see here that this shows that we did 28 operations because we had a bunch of images that we downloaded and processed for both filtered with the grayscale filter and the null filter. So that's the end of running this test example using the console version. We run the ImageTaskGang application with the console version first. This is what that looks like, and we'll run that and you see the results. The next thing we're going to do is we're going to run the Android version of this test just to show something different. So to do that, of course, we're going to have to switch over to Android Studio. Serendipitously, I've got my Android Studio project set up here. I had run this earlier just to make sure it worked. Let's clear everything out. So the way this would work, of course, is if you were running this, you would press the green run button, which would launch the application if it hadn't been launched. In this case, I've already pre-launched the emulator. So here I'm going to go ahead and click on default URLs. So it's going to go ahead and essentially get a bunch of default URLs that I pre-programmed into this thing. And once that's done and it's gotten those URLs, then it should go ahead and give me some options to view the results. So you can see I went ahead and launched the emulator. It's started up, it's connected. Let's make the screen a little bigger. I'm going to click on default URLs, and that's going to go ahead and download those images from the website or from the local device. And now it's going to show me the results of doing this. Here's the results of the null filter. You can see that all the images are in color. Here's the results of the grayscale filter. All the color has been replaced with the grayscale instead, so we can switch back and forth and see the different results. So underneath the hood, the code is basically identical, except for the Android version can't use all the latest and greatest Java features, but it still uses more or less the same code. So now that we've looked at running the applications, let's go ahead and summarize what we've learned from this lesson. We showed how to customize the TaskGang framework using the Java executor framework and, of course, the executor completion service. And that demonstrates the use of many different interesting patterns. We also show how we can use this framework in conjunction with the thread pools and the executor completion service to download, process, store, and display images concurrently. That's also key to understanding how things work. We've got the list of URLs. We've got the list of filters to apply. We have different kinds of output. We have the colored versions. We have the grayscale versions and so on. And everything's then stored locally on the device. We also showed how you can use patterns from the Gang of Four book, like template method, factor method, and decorator. And if you look really carefully, you'll see singleton and command lurking there in some of the code parts as well. And in general, the Gang of Four patterns and the POSA patterns we're about to talk about help make the app and the framework more reusable, more flexible, more portable, and more highly performant and scalable. Here are some examples of the books that we use for the POSA series to get things like Proactor and pooling and future and command processor, if you look at it that way. So once again, this gives us some improvements over not using a pattern-oriented design. In general, using patterns simplifies how you understand software, and specifically, this is for the ImageTaskGang app and the framework. And also, patterns help to see how to extend it. We didn't really talk a lot about extensibility, but it's trivial to add new types of processing. You can inherit from TaskGang and override various hook methods to get a totally different concurrency model. It's easy to change, adding new filters just by subclassing from the filter class and connecting together with the decorators, and so on and so forth. So that wraps up our analysis of the ImageTaskGang application.